A look back at history. At the end of the 18th century, the first steam engines and the intelligent use of hydropower revolutionized production. The late 19th century saw the rise of electrical engineering and mass production. The first moving belt conveyor was used as long ago as 1870 in the slaughterhouses of Cincinnati, Ohio. In the mid-1970s, electronics and IT began to expand rapidly into industry. Siemens developed the first Simatic. Production became increasingly based on computer-assisted controls. The fourth industrial revolution is still a vision. Experts believe that it will only become a reality within the next 20 years. In intelligent factories, everything is interconnected wirelessly.
Several years ago, we tried to embark on a continuous improvement activity with all of our divisions worldwide. We started to see a trend in wearables, VR, AR, we weren't strong on. So we wanted to try to integrate some of that into our current tech and to our systems to see if we could leverage that to give us a competitive advantage. Because we were trying to create a system that could self-generate and be more intuitive than our current reactive systems.
In a manufacturing facility with 40 assembly lines, issues are bound to arise. We want to be able to react to these issues in the quickest manner possible. When an assembly line goes down, a team leader will utilize the Samsung tablet to send an alert to the Gear S3 on a maintenance personnel. The maintenance personnel will acknowledge the alert on their watch and be able to respond to the team leader on the spot. Currently, our approach using radios is a reactive process. Samsung Wearable Technologies will allow us to go proactive and reactive by providing us the stats in the background on mean time to acknowledge and mean time to repair.
Nous innovons avec Immersion en utilisant la réalité mixte pour répondre à un besoin concret. Le contrôle qualité moteur sur notre ligne de production Renault Trucks à Lyon. L'idée est de permettre aux opérateurs d'avoir sous les yeux des instructions d'aide à la décision pour réaliser leurs tâches les plus complexes. Le prototype est maintenant finalisé. Nous passons au pilote en usine et visons une industrialisation d'ici 2019-2020.
Aujourd'hui, quand on contrôle un moteur, on a une checklist imprimée. Avec ce nouvel outil, on n'a plus besoin de papier et on a les mains libres. Une fois qu'on s'est habitué aux lunettes, c'est très intuitif et ça aide vraiment à être plus efficace et à se focaliser sur les contrôles les plus complexes.
Quality is fundamental for our business and very well recognized by our customers. Augmented reality will bring some practical applications in the plant to help us to improve even more the quality for the products that we are delivering. For this reason, as the director of the engine plant, I'm encouraging this implementation of this new innovation. This will place us in the new digital area of development, the Industry 4.0.
This is a major step forward in the provision of services.
Service calls due to plant malfunctions are time sensitive because of the loss of comfort and the need to avoid consequential damages. In cooperation with augmented reality experts UBAMAX, a solution was developed which meets our customers' needs. For the pilot, we selected the remote assistance solution XAssist.
To fix plant malfunctions immediately, service technicians, equipped with smart glasses, are now able to leverage Kiebeck & Peter's entire know-how in real time.
Morgen, Peter. Was kann ich für dich tun? Bin in der Anlage und bräuchte mal Hilfe.
At the service center, our technicians are supported by remote experts who are also able to record video streams of valuable impressions from the plant for documentation and debugging purposes. ROS Clear operating concept displays use case-specific information right in front of the technician's eyes and enables them to focus on their actual tasks on site.
With XAssist and ROS, we are now able to make our know-how available at the customer's plant at any time, offering our customers a unique service level. ROS has substantially increased the efficiency of service and support calls. We were able to significantly reduce system downtimes and response times, as well as time-consuming and expensive travels of our experts to the site.
What if the next big thing wasn't a big thing at all? What if it's a lot of little things all waking up? Your business is part of a global phenomenon called the Internet of Things, connecting people, products, and communities all across the globe.
From manufacturing, critical public utilities, to the shipping of goods. Smart technology has ushered in a new era for the industrial sector.
With Splunk, adopting the revolution of the growing number of internet-connected devices and sensors is easy. Splunk provides a transformative, data-driven approach that shifts your business lens from reactive to predictive and preventive industrial operations. How does Splunk make this possible? Splunk lets you use machine data generated from industrial control systems, SCADA systems, operational technology systems, sensor data, and human data to search and analyze information across your entire environment. With all your data across diverse sources, Splunk makes it easy to monitor and analyze issues, find trends, and detect anomalies so you can fix issues in real time. Splunk shifts root cause analysis into the hands of the people that need it most, the engineers on the factory floor. Create asset hierarchies on your industrial assets, create interactive dashboards, and set personalized alerts with a couple of clicks. Splunk's robust platform has machine learning and AI capabilities built in, so you can predict and prevent imminent outages without affecting production downtime.
Splunk's real-time monitoring and predictive analytics help drive plant performance, improve product quality, and reduce equipment downtime.
The IoT revolution is here. Join millions of users around the world who are rethinking the future of industrial operations with machine data and Splunk.
So we look at the automotive manufacturing process today. It involves tens of thousands of parts from various suppliers. It's a very, very complex process, and it's just hard to keep track of what's going into a car. You have the manufacturers, you have the part suppliers, you have the regulators, the people that are providing financing basically to the entire supply chain. So it's not just about parts that go into a car. You're talking about financing of the supply chain itself. How do you verify the credibility of a supplier, potentially? We're looking at presenting a shared view of the invoices to things like a purchase order that gets into a given contract. Having that common view across all the parties allows a financing provider to be able to reduce the risk that's involved in financing a given supply chain. So IBM is working to apply blockchain technologies in reducing the friction that exists in the automotive manufacturing process. We're really excited in making blockchain real for business.